And welcome to 115th Spletne or Web Hours. My name is Matea, and I will be your host for today, or let's say stand-up comedian in case the technology fails. I don't want to spend a lot of time because we already had a couple of difficulties, and we are short on time for Kirk. So let me introduce you Kirk Zathey from Canada. You can read about him more online. I'll let him introduce himself, but he's from Canada and lives in Murska Sobota. Who figures, right? He speaks English, prekmurščina, and maybe some words of Slovene. But today he will present us how to build an API in Go because everyone actually needs an API for everything. So if you want to make your free to talk to your phone or whatever, you need an API, right? Kirk, the floor is yours.
Thank you, Mate. So hi, everyone. My name is Kirk, and I live in Murska Sobota, and I work for mostly American companies overseas. I've also worked in Ljubljana before for some startups, as well as I've worked for Snapchat in California. So I have a lot of experience on different systems and backend APIs. And so I figured that this kind of talk would be most useful for anybody who's looking to design either a startup or any kind of backend API for any kind of service. I'm going to be focusing on the two technologies, in particular Postgres as well as Go. But you can use a lot of the topics and architecture that we will cover with other languages too, whether that's Java or any kind of backend. So it's more of giving you an idea on how you can build an API simply, and an API that won't lock you into certain technologies or give you issues later on when you do need to scale up. These kind of architectures and technologies can be used with millions of users and easily scale up to the level of a larger company where you'd have the resources to re-architect things and look into more specialized tools. So with that, I'm going to present my screen here if you can see it. Just a second. Can you see that?
Yes.
Okay, great. So this is a small example application I built, and it's using Go for the backend, and it's going to be using Postgres for the database. So to start with, let's go over the database side of things. So hopefully you guys can read it. So on this database, we have 3 tables here, and 3 tables are for users, table for posts. In this case, the example that I'm going to be showing is something like a Twitter or a blog type of thing where you make different posts and people can read them, comment on them. So you have your table here for posts as well as a table for the user sessions. Now, when you do this, you can get with Postgres automatic primary keys and a sequence on the table. You get as well different constraints that you can put on your data. The benefit of this is you know that your data in the table is always going to have these properties associated with them. So in this case, I put like the username has to be at least a length of 3 characters. And this gives you more guarantees than just enforcing it in your application level. So in your Go or your Java backend or whatever language you're using, you can enforce these kind of restrictions as well. But having it on the database itself gives you the benefit of knowing that, even should you build another microservice in the future, or someone goes into the database and updates records manually, they still have to make sure that all of these constraints are met. Otherwise, it won't let you write that data to the table. So we got the password here and created that. Let's take a look at the post table real quick. So we have the ID of the post, user ID of the user who made it, the body of the post, the message, created at, and then we're creating an index on here for user ID and created at so that we can retrieve all of the posts of a particular user in the order of the time that they were created, which is typically how you would retrieve them and display them in a chronological order. And lastly, we have a sessions table to take a look at the active users. So when a user logs in, they get a session ID, and we use that to authenticate them on their requests. Okay, so taking a look at the backend now. And this is, I'll go over why. In particular, I'm showing Go here. So you can build your backend in many different languages. You have Go as an option, Java, tons of different Python, any kind of technologies you want to use. Regardless of the language myself, I would choose to use an architecture like this, where I'll get into it a little bit more, but I'm interacting with the database in raw SQL queries. There are ORMs you can use where you map your data tables and your objects into different objects of the language. So if there were Java, it'd be a Java class, or different objects depending on what programming language you're using. There are some disadvantages to that though, and I find it's harder when you're dealing with other services. So let's say you go to a microservice architecture, or even if you're just using one backend monolith. The problem with using ORMs is you've kind of abstracted away your database. You don't get all of the ability to do more advanced queries, and we'll get into some of the reasons why you might want to do that, as well as the ability to test and to have that visibility into the database isn't there with ORMs. Now, sure, you can use manual queries with ORMs, but then you get into this hybrid approach. It's a little bit harder to maintain and to scale up and to understand. So let's take a look at this backend. I've kept things pretty simple here. In Go isn't an object-oriented language. It's more like a C or other procedural languages. And with Go, you have everything in the standard library that you need. So if you take a look at this app that I built here, it uses all standard library. The only third-party library I'm using is the driver for Postgres. So everything is built into the language. Everything is standard library. Unlike, if you use Java or something, you have to go, well, I can use for JSON parsing, I can use the Jackson library, I can use JSON, I can use 5 different libraries. Sometimes you'll have 3 different ones in the same project, and it can make things a little bit harder because each library works differently, has its own methods. Whereas here with Go, you have everything built in, even the web server, everything is here. So let's take a look here. I have the main method here. This starts the app, just connects to the database, registers a couple different routes. So these are your URLs, and then starts the server. So let's take a quick look at what that looks like here. So my backend's built, and I'm running a server here. If I hit my server with a request. There we go. I can talk to it. I get back a 404 because there's nothing matching that route. Perfect. So let's take a look at one of these basic endpoints. Let's say register a user. So to register a user, I got an endpoint here. This is the handler for it. All it's doing is taking in the request body, parses it as JSON into a Go struct, and then executes this query based on the data that I've given it, so username and password. And you'll see it's just a raw SQL query here. So insert into users, username, password, and then it uses the database itself to do the hashing and salting of the password here, but you can do it within Go if you like. You can even use Go and Postgres. They support the same hashing algorithms, same salting algorithms as each other. So if I run register, and let's give it a username and a password. Username Bob, password. And it gave me an error. See what's going on here. Maybe this got to be quoted. One second, it's my database.
No worries. I think this is like a classical demo.
There we go. Database. Oh, okay. Yeah, I remember what's going on here. So I need to create the database. So let's create the database backend here. There we go. We got a database. Now, if we take a look here, I'm going to just run exactly what's in here, and that's my entire database. So let's run that. There we go. We need our tables to insert into. And now here, like let's say I'm developing this application. If I want to test this query, I can literally copy and paste this query into here, run it directly on the database. I can also run it on the database. In this case, it's an insert. It's not too much of a concern, but if it's a select query, I can run the same query on the database with explain in front of it, which is going to tell me how it's executing the query. So I get to see, how long the query takes, if I need to add an index to that table, all the kind of things like that. And that's the benefit I find of working more directly with the SQL, like less abstractions. When you abstract things away into ORMs, into much higher level languages, it gets to be an issue of understanding exactly what's going on the database level, which, as you scale, as you start to have more users on your apps, you really do need to have, proper indexes on your table, use queries that take advantage of those indexes and give you your data, on a pretty fast basis rather than, having to scan the entire thing. Okay, so let's go back here and let's rerun our query here. There we go, 200, okay. So I just created that user. Now let's log in as that user. So instead of register, I'm going to hit the endpoint log in. There we go. I got a 200, and this is my session that was just created. So now that I got a session ID, we can go here and take a look at how to create a post as your user. So this one, again, it's same JSON kind of request body that it accepts, and it creates a row on the post table. So let's see what that looks like. I think it's new post. Yeah, new post. And I have to pass in the session and the message that I want. So let's do that. I'm going to add my authorization header. And you'll notice for the testing here, I'm just using curl to do it. But obviously, the whole point of having a separate API like this is you can hook this into your web front end that uses React, jQuery. You can hook it into your mobile application that you're building on Android or iOS, or even for internal services like that talk to a different service on your back end. Anything you'd like there. So let's put in our token. So our token authenticates us, and it allows the backend to look up which user it is. So there we go. Hi, everyone. Let's make that post. There we go. The post was made. 200 response. Now let's take a look at the post for that user. So this is a public endpoint to retrieve the posts here. Don't need any auth on that. And my username was Bob. So let's retrieve that. Perfect. Got it back. So yeah, you could use this to build, your own Twitter, your own WordPress type of thing. It's a very simple version of it. But the point here is to just, simplify it as much as possible to just what you need on your database, and basic APIs to talk to the database and to send and retrieve data. In terms of databases that you can use, you can use cloud-based databases like Google Data Store. There's other more modern ones like whether you're using Redis or MongoDB. Unless you have a really good reason to use a special kind of database, and there are some reasons, you might want to use a timescale database if you have a lot of time-based data like metrics. You might want to use a database like BigQuery for things like data warehousing and when you're dealing with large unindexed data. However, for a general purpose API, really your best bet is to stick with the classic SQL databases. So whether that's Postgres or MySQL, they provide you with so many different things that just make your life easier as a programmer, make sure that your data is in a good state, has proper constraints on it for not null or other integrity and check constraints. You get transactional integrity. And even in terms of scaling and the amount of users, you can scale a Postgres database to millions of users without issue. And you can develop on it. You have it locally. If you want to host it in the cloud, you can use something like Amazon RDS, where it takes care of it all for you. It just provides you with the database as a service. So it's very similar to other cloud databases, but you are using real Postgres under the hood, and you have all the advantages of that. So what are some of those advantages? Well, if we take a look at the route here for retrieving the posts. So here I passed in the username as a query param. You see here, post question mark username equals. And then when I retrieve the post from the table, I'm joining it with the users table to the posts table, because post table just has an ID for the user, and the username is in the users table. So I can easily join it like this, grab it for the particular username, and then return it. I load it from the database, put it into a JSON format, and then return it out. So if I wanted to test this query here on the database, let's say I just copy that. Just clean this up a little bit. Bob was the user. I could go run this query. I get back the exact same thing, so it makes it a little bit easier to test. Now, if I wanted to take a look at this query in terms of performance, I had explain in front of it. And there we go. I can see exactly what the database is doing here. I see that, okay, it's using an index scan on users based on that user ID that I was asking for, a username that I was asking for. And then it joins it with the post table. We can see how long that takes to run. There we go, less fraction of a tenth of a millisecond. So pretty fast there.
Hey, Kirk?
Yes.
Sorry to interrupt. Would you mind a question or two in the middle of this?
Sure. Yeah, I don't see the questions here. I'm actually almost done, maybe a couple minutes. So how about I just finish that, and then yeah, I'll be happy to take all your questions.
Perfect. Before you run out of battery. Okay, cool.
Yeah, I still have. Let's see how much. I have 59%. So we're okay.
Go.
All right. No problem here. So a couple other advantages you have is when you're working with Postgres, so you do have to have your schema, right? You do have to define what your tables are. But if you wanted to use unstructured data, all right, more of a document style database, you can use JSON as your column type, and you can put in any kind of JSON string as a column here. And Postgres also makes it really easy to work with JSON. So here, I read out the data as the rows and the columns, and then I used Go to put it into this JSON format here, which was defined as a struct. And you can see here, this was, the post struct for those rows from that query. But if I wanted to, let's say I'm using many different languages because I have microservices. I have one Python, I have one in Go. Here, because I'm using raw SQL, I'm not using an ORM, I can copy and paste these queries directly. But let's say I even want to have the JSON, I want to have everything. You can do that pretty easily with Postgres. You just do something like this, select, let's see, array to JSON, array aggregate, row to JSON from. Now I'm just going to copy and paste this, which is the same query as before. And it should just work. There we go. So now I've returned it directly from Postgres as a JSON string. And I could put this query, copy and paste this into Go, and read this right into a SQL type variable and return that out, or not SQL type, JSON type variable, and return that out to the user. So that way I don't even have to do that within Go. You can like push this down to your database, or you can do it at a higher level. And some of the reasons why you might want to do this, is one, if you're using other services, Python and so on, and you don't want to worry about inconsistent generation of JSON data that might look different from one service to another. But I can also use this to very easily write a query where, let's say I want a query that returns me all of the users and all of the posts for all of the users, or let's say maybe even the first 10 posts, the most recent 10 posts for all of the users in the database. But I want to do that not as a join, where a simple join would give me, one row for every single post, right? I could use these JSON features from the database to have one query where I get one row per user, and then a big JSON value with all the posts here as an array of all their posts in the order that they were posted. So I have a lot of flexibility in what I'm working with. I can even create an index on a JSON column on a particular key in that JSON column to be able to query it the same way I'm querying, for a user here. And then you can double check that it's doing it the right way with your query plans. So anyway, that's the main topics that I wanted to cover here. I'll be happy to take some questions. And yeah, let me switch back to.
Wow, thanks.
Here.
That was fast-paced typing and fast-paced go. Cool. I posted 2 of the questions in chat for your convenience, but I will read them aloud for our watchers. Okay, so what do you think about Gorilla Toolkit in Golang, and do you find it useful for general purpose API, or do you prefer doing it with only standard Golang libraries?
So I've used some of them, like Gorilla Mux, and I think one of the other ones, I forget the name of it. they are useful, and I would say, if you have a reason to use them or if they make your life easier, definitely go for it. Some of the nice things about like GorillaMux, for instance, versus the built-in one that I was using in this case, is it allows you to define your API paths as regular expressions or as different kind of pattern matching where, let's say you wanted to do like a URL like /user/ and then the username, and take that username and have it in a variable. You can do that even with the standard library, but you have to write some code to parse that out of the path. Gorilla does make it a little bit more convenient to use. So nothing against that. If you don't have a reason for using it, I'd say just, don't add extra complexity for no reason. Same with for SQL, like I'm using the default SQL libraries in Go here, but there's also a library called SQLX, which implements everything in the standard Go SQL library, plus gives you some functions that makes it work better and more conveniently. And I'd say, yeah, go for that if it makes your life easier.
Okay, thanks. Now, before we go to the next very complex or maybe, question, let me ask you, what is the computer of facts behind you? We are all wondering what the state-of-the-art machine is.
It's an Apple Lisa.
Okay, like I know what it is. Okay, thanks. So it's not your latest Mac, right?
No, it's not a Mac, it's a Lisa. So it's before
Lisa,
there was a Mac.
sorry.
Yeah.
My bad. Okay, thank you for this clarification. Now, next question. How would you explain concurrency handling in Golang to a beginner? Now, you only have, what, half an hour left?
So a beginner in Go or a beginner programmer? There's a big difference there.
Go.
Oh, beginner in Go. Okay, so you can think of it like an OpenMP task. So if you're used to OpenMP in the C world, it's a lightweight task that lets you schedule work on a thread. I find that they're very useful. They're easier to use than other concurrency in other languages. Very easy to spin up a Go routine, and I'll actually show you a couple things here on this project here. Can you see my? Let's see. Hold on. If you take a look here on one of these routes here. So what I'm doing here with these route handlers is I just call the function directly that does the route. But in the case of where I need authentication, I have this wrapper function that will actually parse out that authorization header, which contains the session, and then continues on with that route. And this next serve HTTP is what actually calls the route here. So the cool thing is, if I wanted to do something else in this route, let's say I wanted to do a simultaneous thread, have something running concurrently as this route is doing its thing, I can do that here. I can have a route to generate log data, or let's say I can create a Go routine that hits my analytics server. So like let's say I have Amplitude or another analytics as a service within my stack, and I'm making an API request to them. I can do that within a Go routine where I go func, and then I just put whatever code I want. And then when this is called, this code is going to execute in a separate thread, and then it's going to continue on with the rest of the work that's happening within this route handler. So I don't have to worry about, let's say, if I have a Go function to make an API request and collect some analytics data for this request, I don't have to worry about that slowing down my request. That's going to happen on another thread, and it'll keep going, even if this API request terminates, completes, and I'm still, my analytics server is really slow. It doesn't matter. That request will still finish out like normal. So it's pretty nice, and you have that flexibility here to put it, anywhere you want. You're not dealing with some heavy frameworks here. You're not dealing with anything that like kind of locks you into how it's going to work. You can define everything yourself, which is why I prefer something like Go over other languages. If you're using something like Java, you can do these queries much of the same way with plain JDBC. All right, make a query, read or write some results, and then parse that data out. With JDBC, there are some more limitations, like you don't have a built-in connection pool to JDBC. You have to get that separately, whereas that's built into the Go standard library for SQL. But when you're writing a web server, a backend in Java, you have to pick a framework, whether that's Spring Boot or you're using something like Kotlin and Ktor, and those have their advantages and disadvantages, but they don't give you quite the level of control without, especially without having this like direct ability to see what it's doing. Right? There's nothing happening here that's magic. Everything is called directly. Even here, when I want to parse out the authentication, the authorization for what are the user routes, I do it here explicitly by calling this function before it calls the new post function. I don't have something like an annotation. I don't have something that happens implicitly or with another file somewhere with some ant matcher defined. It all happens, very explicitly, like from start to bottom. So hopefully that helps.
Cool, thanks. Definitely, I was lost for a moment there. That was question from our audience, so I believe they got their answer. Otherwise, I would get another question. But I might have let's say, a little less development-related question, but still. So you decide how to write an API endpoint, but what if you have to provide this API to other external developers that use this API in their, I don't know, mobile apps, whatever? So can you use any of the existing, let's say, services or something like that that would provide open API, stuff to put in Swagger, so they could see the API signatures, the parameters, maybe try the APIs out? How can you make this work?
Sure. So that, like, you could define, Go docs with your comments. There might be a way to generate Swagger from that. I'd have to take a look. In particular, I haven't generated Swagger docs for APIs before for ones that I've written. But also you can just write up manually saying, these routes, this is how you access them, right? And write up a document file to that. So that's up to you. With Go, because you're not using some kind of framework where you explicitly define everything, like these are the things that the API expects. If you look at some of the routes I wrote, for instance, they accept the JSON body, and that JSON body has different things in there, username, password, and that's just defined as a variable of that type, and then it parses out the raw request body and tries to parse that into that JSON struct. So there's no, like, if you wanted to, like, let's say, generate it in an automated way, there's no like automated way to get that into some kind of documentation. So you'd have to, define your own or do it based on, the method docs, or just write your own docs for that. So yeah, it's up to you how you want to do that. That's a little bit of a separate issue though, from writing it and having it work.
Yeah, I agree. I was just wondering because I'm not that familiar with Go, so I was wondering how do you share your API endpoints with some other people that are not familiar with that. Cool. Oh, I have
yeah, I tend to just write like my own docs for any APIs I write. So I'll just write in a text file. Okay, this is the endpoint. This is
a different new question.
Yeah.
So I will read it out. So are you using any frameworks when developing APIs in Go? What would be advantages or disadvantages of using them?
Yeah, so I kind of touched on this earlier. In this case, I'm not using any framework in Go. For Go, I really don't recommend using anything. You can do it just in the standard library. If you do need some of the things like Gorilla or SQLX to make your life easier, go for it. But in terms of like a heavyweight framework, I think it's just not necessary. And you kind of tie yourself into those when you use them. Because once you start using a framework, you can never really get rid of it. And it's worse if you're tied in, to a framework that's an ORM, and then you cannot just port your code out of there, right? Because you don't even have plain SQL queries. You have that abstracted behind the scenes when you're dealing with these objects. So I find it easier to just avoid using most of the frameworks. I mean, obviously you got to use a framework in Java, at least to serve your web app and stuff like that. But I try to stick with using the standards as much as possible. So your API, use JSON. If your queries, use SQL. Your backend, keep it as simple as possible. That makes it easier for someone else to understand your code, makes it easier to maintain. And should you need to change tool sets or libraries, it's a lot easier to go about that.
Okay, thanks. How are you with the battery? Do we still have time for a couple?
Yeah.
Okay, I got another one about concurrency. So can a concurrent routine hold the entire program written in Go?
It shouldn't. I think you can exit the program, like if you specifically wanted to, and perhaps even an uncut panic might crash the program, something like that. But in general, a concurrent routine shouldn't halt the program. Other than these exceptional cases, like you could have a deadlock, for instance, where Go routine is waiting for a resource and another thing is also waiting for it, something like that, locking contention, which is the same in pretty much any language. But in general, it should not.
Thanks. There are no more questions from the audience, but I might have one additional. So you said you worked for Snapchat and other startups and also Aviate networks in Ljubljana. So
Yes.
did you, in any of your endeavors, use Go for API for backend? Or in all of them?
Definitely not in all of them. For startups, I've probably only used it once professionally in one startup I've worked at. Yeah, I used it for quite a few microservices there. So backend APIs plus dealing with different, background processors. So I was doing some machine learning stuff there, getting it to, backend service that processes data and then, writes out the result. I found in Go, you can find most libraries you need, but if you do need something like kind of niche, like a machine learning library or something like that, you can import a C or C++ library pretty easily. So I use Go in those cases. It's like a C. It's very similar to C, but it gives you that garbage collection, memory, safety, and other features that you get in a more modern language.
Okay, thanks. Would you like to add anything else? Because I don't have any questions and audience doesn't have any questions. So if you want to add something, why, for example, you Go or additionally to your presentation, or I don't know, to encourage people how to start with it or where to try it, please. Now is your
Sure.
5 minutes.
So like for my talk, like Go, I think is a good tool. I think it's a good language. I don't think it's the only way you can go. As I mentioned, there's Java, there's other tools. I did want to stress in this talk though the benefits of using more traditional proven technologies like Postgres as your database, like raw SQL queries. It gets you. It makes your life a lot easier down the line. It makes it easier to build up your team, have people understand what's going on. So try out Go, try out Postgres. Some of the resources I would recommend is Postgres's documentation on their website. The official one is really good. As for Go, there is the Go tutorial and Go Playground that I would check out. There's also a really good book just called The Go Programming Language that will kind of teach you everything about Go, concurrency, web servers. I do find with Go, it is a lot easier to work with Go code. Like this example that I showed you, it was three source code files, and the total amount of code there in Go, I'm looking at it right now, it's about 300 lines of code in total. So it's a far smaller code base than doing the same thing in other languages. Plus, you're not pulling in all these third-party frameworks, all these, heavy libraries and everything else into your project. You don't have to, teach people how functional notation works, or how your specific objects and object mappers work. Nobody needs to know that, right? If you know SQL, if you know how a web server works, what a web request looks like, how to parse out a header, what they're used for, you're up and running. Like, you have everything in your standard library to run a web server right there, and you just execute the program. And it's up to you whether or not how much you want to use Go versus other technologies. Like the example I gave for hashing the password, you can do that in Go. They have built into the standard library functions for hashing passwords and verifying passwords, and you can use those same functions on the same password hashes that Postgres makes. So it's your choice if you want to do it there. Same thing with if you want to run encryption, HTTPS on your web server. Yeah, you can do that in Go, built in. But I find, in actual production systems, it's easier to just run something like Nginx, which you're going to be using anyways, or some kind of load balancer that does the SSL termination for you, and then it can just call your Go service directly. Of course, that's an architectural decision to you, but with Go, it makes it really easy to decide what you're going to do, right? You're not tied into doing authentication one way because I'm using this framework, and this framework wants its session tokens in this format and looking like this. And if I want to change anything, that it gets really complicated, and then nobody's going to understand what I'm doing. And all of these issues here, you decide what you want to do, and then it's very easy to do whatever it is that you've decided on.
Thank you. At this point, I would like to thank you for your time. It was very educational, informative, and I believe that for Go fans, also fun. For the rest of us as well, hearing you type and watching you, how you dug out of this demo, curse at the beginning. So thank you very much. It was cool. But now I would like to give, let's say, spotlight to our next guest. With this online season, we introduced Web Minutes. And this means very short lightning talk, presenting one or other interesting topic for web developers. And with us here is Alexander. Alexander, correct me if I will pronounce your surname wrong. So Palchikovskiy.
No? It's okay.
Okay, it's okay. Palchikovskiy. Okay.
Also, there was one thing I just wanted to add, because I know you're discussing functional programming, right? So I like functional programming. Functional programming is great. I just don't like working on other people's functional code. Because it can get kind of complicated, but it's good. I think it's a great topic, so looking forward to it.
Kirk, please stay with us if your battery allows it. Okay?
Yeah,
I believe you can ask better questions than I can if Alexander will be up to some questions. Cool.
Okay. I'll also get on my other computer to watch in any case.
Okay.
Thanks.
Thanks. Okay, Alexander, he will explain us why we should choose Erlang or Elixir over, he said, insert latest or greatest programming language. So we can insert here Go, right? He will show us the strengths and why we should be interested in using Elixir. So, Alexander, the floor is yours.
Thank you very much. My name is Alexander. I am from Ukraine and relocated to Ljubljana just a month ago. So I am new here, but happy to take part of meetup, and hope that my short speech will be interesting for you. Today we'll talk about two similar languages, very interesting. One of them is Erlang, the other is Elixir. My talk is short today, so we will not dive deep. And my goal is just to tease you with examples of successful projects and give you an idea about why I'm so excited about these languages. So when we talk about Erlang and Elixir, they both are functional, dynamic typed, and work it on the virtual machine. The Erlang is the base language. Elixir is a macro extension of Erlang in Ruby style. You can use Erlang calls in Elixir and Elixir calls in Erlang. So That is why I will talk about each together. So why we should use it? There are at least 4 reasons: robust, scalable, fast and concurrent world, and less code. I will illustrate it with examples. Many languages were created first for general purpose, and then they were used for specific practical issues. On the contrast, Erlang was specifically created to solve 2 big problems of telecom software. It had to be robust and scalable. Erlang was created in Ericsson in the early 90s. At first, it was scientific language in the Ericsson lab, but then one of the new Ericsson C++ projects failed, and Erlang was chosen to save the situation. And our story of unbelievable success has begun. The first Erlang project was Ericsson's telecom switch AXD301. In 2002, it was chosen by British Telecom, and look at these numbers. 14 nodes carries for live traffic, 40 million calls per week node. It's around 500 million calls per week. It looks outstanding in 2020, but in 2002, it was absolutely mind-blowing. And everything is with reliability of the system with 9 nines, 99.79 after percent. It's some kind of 6-second unreliability for 20 years. How is it possible? The main source of mistakes in the program is usually that a variable doesn't have the expected value. Erlang creators solve this problem really elegantly. No change variables, no problem. So Erlang operates with functions and lightweight async processes. Each one is absolutely independent of the others. They don't have shared memory. They don't have side effects, which means that when you are inside a process or function, you can't change directly something like a global variable outside the scope. When you want to change something outside the process, you have to send a message or return value if you talk about functions. So imagine a system where you have 100 million small processes which are working absolutely independently. They send and receive messages. If some of the processes die, others will be idle and just wait for messages from them. But others will work as if nothing happened. It looks like ideal microservices architecture, doesn't it? And you have it out of the box without any additional and that's not all. When some of process unexpectedly stop to answer, what we'll do with first? We will try to restart them. And Erlang again can do more than we expect. When we create process, you can do it with several levels of watchers. Watchers processes called supervisors, which receives messages from fallen processes and can restart it automatically or handle it or do nothing. And all of it is out of the box. And the last but not least, when you have to fix code, you can do it without interruption of any other processes. Erlang supports really hot reload code. So from defining programming when you are trying to not have mistakes in your code at all, Erlang realizes other approach: let it crash. When we talk about 9 nines reliability in the British Telecom example, it doesn't mean that the system didn't have mistakes. It means that the system works well enough despite mistakes. Let's talk about scalability. These are two examples. One of them, the WhatsApp, is the biggest messenger in the world, which now has more than 2 billion users. The second example is not famous in Slovenia, but very famous in Ukraine. It's private bank. It's the biggest bank in Eastern Europe. It has more than 60 million financial transactions per month. You understand what is reliability you have to do with financial. It's not it's not about messaging. So it's really fantastic, and it couldn't happen without Erlang. Both of these applications have Erlang in their backend. Let's talk about speed. So, as I mentioned, Elixir is a macro extension of Erlang. It was created in 2011 by José Valim, one of the creators of Ruby on Rails, and his Elixir web framework Phoenix is his attempt to save benefits and solve Ruby on Rails problems. With multi-core CPU, Elixir will faster in 10 times than Ruby by benchmark of 2014. I don't have fresh benchmarks, but I am sure that Elixir will faster on multi-core CPU because it works on the Erlang virtual machine with natural scalability. Look at the picture. Virtual machine beam, Erlang virtual machine beam, creates an operation systems thread for each CPU's core. And after that, all processes under this scheduler working absolutely independently. There is, as I mentioned, there is no shared memory, shared data. So when you have, it doesn't matter how many cores you have, all of them will use it to the maximum. And that is why Elixir or Erlang will be faster than any other languages. It will be slower when you have only one CPU, but when you have a lot of CPU core, Erlang and Elixir will be much faster because they can do it really simultaneously. And the last feature, but not least, which is my favorite, is less code. This is an example of quicksort algorithm on Erlang, created with language primitives. It's only 2 lines of code. This algorithm without recursion has around 50 locks by Java. Okay, honestly, it's not the best example because this operation plus is greedy. So in the real world, we don't have logarithmic speed. We don't have logarithmic speed here. But as the illustration, I think it's quite good because it's just two lines of code, and it's amazing. In my experience, I have to do quite difficult task to find the best suitable by many criteria warehouse cells suitable for the goods. I did it with 2 languages. One of them was a traditional procedural language with C#-like syntaxes, and I had something around 5,000 lines of code. 5,000 lines of code. In Elixir, with the same functionality, I have only 500 blocks, so it's 10 times less, and it's true. So I hope it was interesting, and that's everything what I want to say for today. I hope it was just a teasing. So I hope that we will have interest into the topic, and we will talk about it later with deeper insight. But I hope it was interesting today.
Thank you,
Thank you very much.
Alexander. Thank you. It was
Thank you.
interesting. I have a question. I have a teaser question for you.
Okay.
Now that you work with Erlang, do you think that now you have a hammer, right? And now everything you see is
Yeah.
like a nail? No? Do you think that Erlang is actually okay for everything you do, or do you have to pick your projects wisely?
I really don't want to change my language today because it's really cool. It's really amazing. I like it very much, and I think you can solve everything what you want with this language. So especially in real business world. So there are really great web frameworks with amazing scalability, reliability, and speed, more than 10 times faster than, for example, Ruby on Rails. You can use it with great business process engine with which has only 200 lines of code, but it works. And in my opinion, the Erlang's architecture is something like similar to real world. So any real world task can be solved with it, because in our real world, we all absolutely independent. For example, 6 billion people live at the same time, do something independent from other people. So it's everything what Erlang proposed to do. So when we have to describe the real world situation, the Erlang or Elixir way of thinking is something similar of what we have to do. I think it's not suitable for mathematical or really big computational tasks. But when we talk about business, and for example, especially for web development, I think it's really cool, and it's maybe something the best languages for future, especially Elixir, because Erlang is something for it's old school. It's for hackers. Elixir is much more friendly to the users. Don't have much more similar to the modern languages, and have really big, quite useful tools. So I think in the future we will work with Phoenix instead of Ruby on Rails.
Okay, thank you. This is the answer I was expecting. Thanks. But maybe before we conclude this, where can we find community for Elixir? Where do you guys hang out? Where do you exchange your experience or?
When we talk about Elixir, there is a really big Elixir forum with great support. But I started to learn Erlang at first through the books, and after Erlang, Elixir was quite simple because it's the same, but with different syntaxes rules. So Stack Overflow has enough options to respond, but it will be better for you if you have not support somewhere, but you have somebody who knows the language and can help you at the beginning. When you started to code, everything will be great because it's really amazing.
Are there any, let's say, influencers or mentors that we can look up to in Erlang or Elixir? Do you know any people we should follow? Or
in my opinion, there are two great maintainers these days. One of them is Jose Valim, is the maintainer of Elixir. It's something like how it could be cool for everybody. And there is one guy in Ukraine, Maxim Sahatsky, who is on the age of Erlang, and he has absolutely unlimited creativity, and you can't use it. You can't use this because it's too he made changes too fast. But his ideas could be great for long time working. So this was my path. I worked with Maxim, and it's too fast for me. I think it's because in his imaginary world, not suitable for real business needs. But when you want to learn something and to do how to do it, it's a really great person. So I'm happy to be with him. So I recommend two persons: Maxim Sahatsky as a creator of Envoy framework, and Jose Valim as a creator of Elixir framework. These two frameworks, I think, it's more than enough for web development.
I agree. Okay, thank you. With this, I would like to conclude this Spletne Urice. But before we leave, I have a task or two to do. Okay, so as you know, we have a website. Go check it out. Follow us on YouTube, on Facebook. Subscribe to mailing list. We don't spam, we promise. And if you want to have a lightning talk, please contact us. We'll be glad to host you here online, and so you can spread your love for web development technologies, and you can share your opinions with other like-minded or not so like-minded people like us. But we love you anyway. So please join us in 2 weeks. That's it. So stay negative, people, right? In these days, staying negative is positive. And see you next time. Bye-bye.
Bye-bye. Thank you very much.